This is part 3 of our lesson on equation of a transformed function. So in question number 2, it says transformations were applied to the function y equals sine x to produce the following graph. Determine the transformation equation. So I would probably start with just the generic equation of a sine function, and then we'll try to figure out what a, b, h, and k are. So I'm going to use this space here to do my calculations. So I think I'm going to use this space here to write my equation. So I'm maybe going to call this just f of x. And it is a sine graph. So I'm going to say it equals a times sine of b times x plus h plus k. And our goal is to figure out what a, b, h, and k equal. Okay, so I'm going to zoom into this graph a little bit, make it bigger so that we can see a little bit better. So a, b, h, and k all relate to different features of the graph, right? K traditionally is the midline. H is related to the phase shift, A is related to the amplitude, and B is related to the period. So I know this is a sine graph. The first thing I'm going to find is the midline, because I need to know the midline so that I can find one cycle, and then once I have a cycle, it's easier to find your amplitude and your period and your phase shift. So I'm going to start with the midline. So over here, I'm going to write for the midline. I need to switch markers here. For the midline, there's two ways you can find it. Number one, you could look at your graph and try to find where you think the middle horizontally is. Otherwise, there is a formula that is max plus min divided by 2. The maximum of this graph, we're talking about the y value. The maximum y value is 6. The minimum y value is -4. So I'm going to do 6 plus -4 divided by 2. Now 6 plus -4 is 2, and 2 divided by 2 is 1. So the midline of my function should be at 1. So that means if I look on my graph where y is 1, that is where the halfway point of my graph should be. Right? If you were to check, there should be the same number of squares to the top as there are to the bottom. So this is 1, 2, 3, 4, 5 squares up, and 1, 2, 3, 4, 5 squares down, which tells me that I have the midline in the right place. Now, once I have the midline in place, sine graphs always start on the midline, right? Cosine graphs start at either the top or they start down at the bottom. Usually they start at the top. Sine graphs always start in the middle. So I want to try to find a point where my graph would start on the midline. So I could pick this point here as my starting point, where it goes down and then up. That would be an upside down cycle. It would be one that's been reflected. I could pick this as my starting point, and then it goes up and then down. That would be a regular right side up sine curve. I think I'd like to pick this one. So I'm going to say that we're going to start at this point here. And then one cycle of sine goes up, back to the midline, down, back to the midline. And then that pattern just repeats itself over and over and over again. So in doing that, in highlighting that graph, that helps me find my phase shift. So the phase shift is just the x coordinate of that first point on my graph. Now, normally when we graph, we have our scale in pi over 6s, but that's not what my scale is here. Actually, my scale here is just that every square is 1. So this first starting point has an x value of -3. So that means that my phase shift is -3. And we'll talk about, oh, I didn't even see where I wrote that down. We'll talk about where that shows up in our equation in a minute. All right, from here, we've got midline, we've got phase shift. The next easy one to calculate is the amplitude. I always do the period last because it's weird. All right, so for amplitude, there are a couple of ways you can find it. So the amplitude is half the height of your function. So one way you can do it is you can count from the midline to the top or from the midline to the bottom. So this is 1, 2, 3, 4, 5 squares. And then every square here is worth 1. So 5 times 1 is just 5. Now on a lot of the scales that we use, every square is a half. So I would do 5 times a half, which is 2.5, right? So you want to use the scale, right? Count how many squares and then apply the scale. So this would be 5. So the amplitude of my graph would be 5. You can also get the amplitude by doing max minus min divided by 2. So I think I'm going to write that down just because it's our note. So max minus min divided by 2. The maximum is still 6. The minimum is still -4. So I am subtracting -4. And then that is divided by 2. 2 minus signs in a row make a plus. So 6 plus 4 is 10. And then 10 divided by 2 is 5, right? Which I got from counting. So it's up to you if you want to just count it out. That's fine, right? Count from the midline to the top or from the midline to the bottom. Or you can use the formula. All right, last up is the period. I'm going to do that over here. So for the period of the graph, we are looking at how long is one cycle. So from my starting point to my ending point, I'm going to count how many squares and then apply the scale. So this is 1, 2, 3, 4, 5, 6, 7, 8. Now if I have 8 on the top half, there has to be 8 on the bottom half, which would make 16. But I'm going to count just to be sure. So I'm at 8, 9, 10, 11, 12, 13, 14, 15, 16. So it is 16 squares. And every square is not worth pi over 6. Normally I would do 16 times pi over 6. Every square here is just 1. So 16 times 1 is just 16. Okay, so I have identified the midline, the phase shift, the amplitude, and the period. And then I want to try to figure out how those relate to A, B, H, and K. So up first, the midline is just your K value. It moves as the graph is moved up and down. So K is just going to equal 1. It comes from the midline. The phase shift, that's the left and right part, is -3. Now that would be my H because H moves it left and right. And it's always opposite what you would think. So since my phase shift is -3, my H value is going to be +3. Now the amplitude, I said, was 5. Now, depending on the cycle I chose, A is either 5 or -5. It's one or the other. And I can tell by looking at the cycle that I chose on my graph. Because I chose a cycle that goes up first, it is not a reflection, so it would just be +5. If I had picked the cycle that started over here and it went down first, then that would be a reflection, so it would have to be a -5. So in this case, because my cycle goes up first, I know it's not -5, it's +5. All right, and then the last part, the trickiest part, is my B. That is not 16, right? The period is 16. Normally, the period of a sine curve is 2 pi. So there's two ways to work this out. Number one, you could ask yourself, what did I do to a 2 pi to turn it into 16? Or you can use the equation that the period equals 2 pi divided by b. So sine and cosine have a regular period of 2 pi. So I know my period here is 16, and that equals 2 pi over b. And then I would cross multiply to get the b out of the denominator. So I would get 16 times b equals 2 pi. And then I would divide by 16 to get that b is 2 pi over 16. Now 2 and 16 both divide by 2, so that would be 1 pi over 8 if I divided by 2. So that means my b value is pi over 8. Now, if you wanted to just puzzle it out instead of using the formula, I would say to myself, okay, I have 2 pi normally, and now my answer is 16. So what would I have to do to a 2 pi to turn it into a 16? Well, I would need to divide out the pi so that they would cancel out, and I would have to multiply by 8 to turn that 2 into a 16. So I would have to divide by pi and multiply by 8 in order to make this 16. Multiplying by 8 would be a horizontal stretch of 8. And then dividing by pi would be a horizontal compression of pi. So if I want to stretch by 8, that would be 1 over 8 as my b value. If I want to do a compression of pi, then that would just be a pi. So I would combine those two together by saying it's 1 over 8 times pi, or pi over 8. That's a tricky one to figure out. It's easier when they still have pi's in them. Sometimes the formula is a little bit easier to work with. You just need to come up with something that makes sense to you. So now that I have my a, b, h, and k, I'm going to finish this off by just writing my final equation. So this is f of x equals positive 5 times sine of b, so pi over 8, times x plus h, so x plus 3, and then plus k, so plus 1. And that's my final equation. All right, you can join me in the next video to learn how to do question number 3.